We have a good number of things to cover, some of which will be new concepts, and many of which will be things to illustrate those concepts. And we'll start by talking about how objects in Windows PowerShell are really just a type of data structure, just another word for a type of data structure that you can have. I'll show you how to use PowerShell commands to explore those objects and where you can go online to find documentation on those objects. We'll also talk about one of the things that can be a little bit confusing about PowerShell objects, which is the ETS. It's extensible type system and object adaptation, which means sometimes when you're looking at the documentation, you're going to see something different than you see inside PowerShell, and I'll explain why. We'll talk about the members of an object. That's its properties, methods, and events. And then to give you some concrete examples, we'll play around with some date, time, and some string objects. Focus on a little string manipulation and some date manipulation. Very useful techniques in and of themselves, and a great way to get a feel for how all this stuff really works. Windows PowerShell is written in the .NET framework, which is an object-oriented language. And Windows PowerShell is actually an object-oriented shell. Now, some folks don't get too bothered by the phrase object-oriented. Some folks immediately kind of throw up their white flag and say, look, I didn't sign up to be a software developer. Don't talk to me about this object-oriented stuff. But yeah, it's okay. PowerShell actually does a lot of things to simplify it. And the fact that we have objects to work with is one of the things that makes PowerShell not only powerful, but it makes it unique amongst command line shells in the world. So let's take this one step at a time. You've seen me run commands like get service. Now hopefully you and I can agree that the output of this command is a table, right? It's got columns, it's got rows. In fact, you could probably imagine a structure very similar to this one existing in something like Microsoft Excel, where you've got individual columns going down, and each row contains the columns for one particular piece of information, right? So if you can agree to that, then all we need to do is change some terminology. This entire thing is not a table, it is a collection. Each of these is not a row. Instead, each row is an object. So the entire table is a collection of objects. Each column is a property. So this collection is displaying 3 properties for, I don't know, probably 100 or so services, 100 or so objects, right? If you're good with that change in terminology, then we're going to get along just fine. So here's how you can actually see that information. Any PowerShell command that produces output to the pipeline, and review the previous nugget if you're a little confused about output to the pipeline, any PowerShell command that puts output in the pipeline, and for the most part that means if it puts stuff on the screen, it puts it in the pipeline, you can pipe that to a command called getMember. Now, this is a command you should be using so frequently that typing get-member starts to make your wrists hurt. So you're looking for the alias, which is GM, not the car company, not genetically modified. It stands for getMember. And what it produces is this complete list of information about whatever objects that command produced. It's telling me that that command, getService, produces objects of the type system.serviceProcess.serviceController. That's the unique name that describes this particular data structure. Now look, when we ran the command by itself, you noticed it produced 3 columns, right? Status, name, and display name. You know there's more information available than those 3 things, right? There's its current start mode, its logon account, its dependent services, its executable name. There's all kinds of other information. Well, when you run a command, PowerShell produces a table, a collection, containing all that information, all of those properties. But it knows it can't possibly fit them all on the screen, or it expects that it can't fit them on the screen. So there's literally just a bunch of configuration files sitting on disk that say, look, if he runs this command and he didn't tell you what he wants to see, just default to these properties. Well, getMember is how you can find out what else is available. Anything that has the word property in it. Alias property, property. See if we scroll down a bit. We've just got those 2 types. But anything that uses the word property in it is something that you could potentially display in a column of the output. Now, an alias property is actually something that PowerShell adds, and this is a good time to kind of jump into finding the documentation. The help system in PowerShell does not document objects. So instead, I'm going to copy this type name to the clipboard, open up my web browser, and I'm going to paste that in to my search engine. Dooby-dooby-doo. I didn't really want it to do HTTP, but thanks. Just search for that. Oh. Search for it there. Probably the first hit you get when you eventually get it to search is going to be the right one. It'll always be to MSDN, and we're looking for a system.serviceprocess.service controller, so let's click on that. And you can pull out this little tree view here to kind of give you more information, and you'll see it's willing to give you a list of all of its properties. So we've got things like service name. If you look here, this is alphabetical, right? A, B, C, D, E, M. There is no property called name. There's just service name. This documentation is a good way for you to figure out what some of these properties actually mean. Service handle is the handle for the service. Service name is the name that identifies the service. Service type is the type of service, that type of information. So it's good to have this documentation. But understand that PowerShell has an extensible type system, meaning it can actually add stuff to this thing in runtime dynamically. So this entire list that was produced by getMember is a list of the object's members, which includes properties, events, which are things that happen to the object, and methods, which are things you can tell the object to do, like starting or stopping a service. So of these members, some of them were born with the object, and they'll be documented on the MSDN webpage. Some of them were dynamically added by PowerShell's extensible type system, including alias properties. PowerShell hates it when objects don't have a name property. Everything should have a name. Well, service objects have a service name property instead. And so it's listed right here all by itself as a regular property. So PowerShell adds an alias to that so that it also has a name. Now, there's also a required services, which is actually the same as the underlying services depended on property. It's just another alias. You'll see these a lot. Let's run get process and pipe that to GM. This is a big list. Alias properties tend to go at the top. So instead of handle count, we can just refer to handles. Instead of process name, we get a name. Same thing as it did with services. Instead of having to type non-page system memory size, we can just type npm. So these alias properties are sometimes just a little shortcut. We've got some events down here. So there's an exited event that will run whenever a process exit. That's a good way to respond to that. And there's a bunch of things you can do to the process, including kill it. I love that one. It's probably a little bit visceral, but hey. We've also got some script properties at the end, which again are things added by PowerShell. You see, it turns out that things like the company and the CPU and the path for a process are actually a little bit difficult to get. And so this script property is added by PowerShell, and it executes this code under the hood to make that information a little bit more accessible to you. So PowerShell is doing a lot of things to adapt and extend this object. If we look at the help for getMember, you'll notice a number of switches. First of all, you can have it display just certain members. Only show me the alias properties or the script properties or whatever it is you're after. You can also have different views. Show me all the members. Just show me the base object. Show me the fully adapted object, or show me the extended object. So let's take a look at some of those differences. Let's do it all with getProcess. We do apples to apples. So view all. That's what we've really been looking at. That's everything. Alias properties, which are extensions, everything. Let's change it now to just adapted. So the adapted object is the one that has not yet been extended by the extensible type system. In this case, we're just getting the base object plus any mandatory adaptations PowerShell has had to make the thing work. If we look at the extended object, that's when we get just the extensions PowerShell was adding. So these are all the things that won't be documented in the online documentation because PowerShell just added them. Like right now, it just put them in there. And the last mode is base. And this is just the raw object as it was born, as it came out of the .NET framework. And these are all the things that will be documented on that MSDN web page because these are the things that the object was actually born with. So there's a lot of different ways that you can use getMember to see different versions of the object. At the end of the day, you always get to play with the fully extended object, which is what getMember is showing you by default. It's a combination of the extensions as well as the base things that that particular object was born with. So let's spend a little time playing with a slightly simpler type of object that we can really do some fun stuff with. I'm just going to put a string into a variable. Oops, I guess I should type the variable name first, huh? X equals hello. If we pipe X to getMember, we can see at the top of the list that the type name is system.string. This is a string object. It's got one property that we can play with, length, x.length. Now the dot is called a member resolution operator. Here's how I like to think of it. I don't want to do something with the entire x object. I just want to do something with a piece of it, the length piece, a fraction of the object, if you will. And in math, we use a decimal point to refer to a fraction. So I'm telling it, I don't want the whole x, I just want a piece of it, and the piece I want is the length piece. 5, that's how long that particular string is. Now let's play with some of the methods, because these are fun. Here's the replace method. I want to replace all instances of LL with XX. Oops. Notice how I left out that single quote at the beginning of XX? That's why I did that prompt there. So I'm going to pull that back up, put that in there. Now that did not change the original thing that was in X. That produced a new string where the LLs had been replaced by XX. You can see that if I just look inside X, it's still the original thing. X to upper. Now to upper doesn't require any arguments, so you still have to put the parentheses, and there cannot be a space between the method name and the opening parenthesis. That'll give me an uppercase version of it. There's also to lower, and none of those have modified the original contents of X. What else have we got in here? There's all these other fun methods. You can kind of get a little bit of a view. For example, here's to upper, and you'll notice that it does not include anything in the parentheses. So that's kind of telling me it doesn't require any other input inside those parentheses. Whereas replace does. It wants the old character and then the new character, or the old value and the new value. So you can kind of get a brief look at the syntax here, especially if your PowerShell window is really wide. Otherwise, if it's not wide enough, it'll truncate this information. But if you really want to learn how to use these things, you're probably going to want to jump into the documentation. So here's what I'll do. I'll push the type name in here, system.string. Oh. System.string. I use too many versions of IE, I can't remember the right thing. So here's the string class. And this time I want to go look at the methods. And if I was curious about how to use the replace method, I could scroll down to that. I could see there's two versions of it, one that takes a single character in each argument, and another that takes a complete string of multiple characters. I can click on that. And then I can even get some examples. The C# examples are the ones that are going to be probably the most applicable to PowerShell. They're going to be the closest. And here you can see it using replace, feeding it two strings. So replacing document with document. So if you do need to learn how to use some of these methods, this is the right place to go about doing it. Let's close all those tabs out. So it's a string object. There's definitely a lot of fun things you can do there. You can trim the string, you can pad the string, convert it to upper and lowercase, do all kinds of crazy stuff with it. Now let's play with some dates. There's a command in PowerShell. Well, you know what? I should make you do this. We got a bunch of things called date. We're looking for commandlets. We got set date. There we go. Get date. That's the guy I want to use. That's a date. Let's put it in a variable so we can play with it. Dates have got a bunch of cool things you can do. First of all, they've got properties that let you extract just a particular piece of the date. So d dot hour, that's the hour I ran this. D dot day of week, I ran this on a Tuesday. At least my computer thinks it's a Tuesday. It's possible I have not set the clock on that correctly. There is this many ticks on the clock at the time. And then there are some methods. These up here, and the methods usually do conversions. For example, d.to short date string produces a shortened version of the date. I could say to local time. That will produce a local variant of it for a time that was in UTC. We've also got some that will modify, add minutes, add months, add years. I love these things. You want to find out what the date is in 90 days? Add days 90. Now here's a trick. If you go back and look at this list, you'll notice there is a subtract method. But if you look over here at the documentation for it, it tells you that you have to give it a date time value. Meaning you have to tell it what you're subtracting. Are you subtracting days or hours or minutes? There's also an add method that does the same thing. But then you get all these shortcut ones. Add days, add hours, add milliseconds. I like to use those because the syntax is easier. So if you want to find out what the date was 90 days ago, add a negative. And imagine that you're going to be doing some rotating of log files. You're going to archive off the old log files, delete the oldest archive one. This is a great way to calculate the dates that you would need to do that. You know, IIS log files, for example, take the form ex year, month, day.log. Well, you can certainly extract all that information. $D year, right? $D day. You can get all those different pieces of information out and use them to construct the file name for 90 days ago. You can do this thing called chaining. Now, here's the trick with this. If you look at this, if I just look in D, that's what a date time object normally formats itself as. If I add -90, I get that same type of format, right? I don't know why it did. Oh, because I didn't use add days. There we go. So it appears to me as if D contains a date time, and the add days method produces a new date time. We can verify that by just piping it to get member. Yep, sure enough, that produced a date time also. You can see there on the type name that it's a system.datetime. Well, that means I can do something like this. I took a date, I ran its add days method, which produced a date, so I took the new date's year property. All right, you can ping those things together as much as you want to. For example, to short date string will produce the short date string for 90 days ago, or 90 days after whatever date is in D. So you can chain these methods together, and if you just want the year out of that or whatever else, you can continue to chain those things together so long as each method is actually producing a date time object. Now let's see what happens. What is this producing? See, that's not a date time anymore. The to short date string produced a string. So I could not put year because a string object doesn't have a year property. It gives me nothing. I wish it gave you an error message, but it doesn't. Length, on the other hand, is something a string does have. So I took my date time, I ran its add days method, I ran the to short date string method of that, and then I got the length property of that. So you can do all sorts of neat things by chaining these together, and you'll see folks do this, and even if you choose not to do this syntax, I think it's important that you be able to recognize it and at least have an idea of what it's doing, so that when you're repurposing someone else's work, if they've taken that approach, you at least recognize it for what it is. Okay, one more short set of examples. Let's get procs and put all the current processes in it. Now you should remember that I can use an index number to refer to a, whoops, did I not? Oh, procs 0. I can use an index number to refer to a particular item, But now that I have a particular item, I can use a dot and any of its properties. So let's do this. I'm going to run Notepad because I need something safe to kill. Let's set procs equal to get process name Notepad. Let's just verify before I break something. Okay. Procs 0 is going to get me the, whoops, see, it's not a whole bunch of things. There's only one. Let's run a couple more copies in Notepad. See, I couldn't refer to just the one thing because there is only the one thing. Now, if I run this, procs contains 3 things, and I can definitely refer to the first one. It's CPU utilization, it's paged memory, and I can execute its kill method. Now you watch down here in my taskbar, you can see I've got three copies of Notepad. You can kind of see the 3 buttons there. One of them just went away. So now I've only got 2 left. If I hover down here, it should show me I've got 2 left. Now if I look at procs, it still has 3 pieces of information in it because it's a snapshot at that particular point in time. One of these no longer has CPU information because it's no longer running. So you can kind of see how having the information in a variable does not necessarily update itself. So if I try to run procs 0 kill again, I get an error. I can't kill it because it's already killed. It's already been exited. I can't call the kill method anymore. So you might think to yourself, what if I've got a whole bunch of stuff? Does that mean I have to do 0 and then come over here and do 1 and then come over here and do 2? Yes and no. For what I've shown you so far, you definitely do have to do these one at a time. But we're going to be working our way into some commands that will go through them all for you. When we get there, I want you to remember that we had to do this so that when I show you the shorter, more efficient way, it makes a little sense to you and you appreciate the efficiency. So objects are just a different type of data structure. You can think of them as a table, like an Excel spreadsheet, and if remembering that sort of a row is an object and a column is a property helps you get through the terminology, then fantastic. Keep in mind you've got that getMember or GM command, and it is going to be one of your best friends. You should definitely get in the habit of using that on objects so that you can see what you're dealing with. I showed you where to find the documentation, and that'll help you maybe get some more background details on the base members of an object, but keep in mind GM is going to show you stuff that isn't in the documentation, but was instead added dynamically by PowerShell as part of its extensible type system and object adaptation routines. So that's all the members, the properties, the methods, and events of an object, and we got to play around with some of those, using date, time, and string objects. Very useful tasks all by themselves, and a good set of examples for all this objecty stuff. I hope this has been informative for you, and I'd like to thank you.